So thank you for tuning in to Operation Calculation again. This is Myra Myers speaking, and today we'll be talking about graphing linear equations. Now, you've probably seen this before when you're asked to graph an equation that's similar to y equals 2x plus 1. And you even may be accustomed to choosing your x values to plug into the equation so you can get y, which will look something similar to this. Well, I decided to do the same thing. I chose 5x values and I plugged them into the equation so I can receive my x. I went from negative 2 to 2. And as you can see, I plugged in each of the x equations in their own respect, each of the x variables in their own respect into the equations, and I found my y. When I plugged in negative 2, my y was negative 3. I plugged in negative 1, my y was negative 1. When I plugged x as 0, my y was 1. When I plugged x as 1, my y was 3. And when I plugged x in as 2, my y was 5. And I used these coordinates to graph my line over to the left. I went over to negative 2 on the x-axis and down to negative 3. I plotted. I went to negative 1 on the x-axis down to negative 1 on the y-axis. I plotted. When x was 0, I plotted 1 on the I plotted 1 on the y-axis. When x was 1, I plotted 1 and 3. And last but not least, it was 2 and 5. And as you see, this way I was able to graph my linear equation. But what if I told you there was a simpler way that we could have graphed that? Well, the equation y equals 2x plus 1 is in a form we call the slope-intercept equation, where the standard equation is y equals mx plus b, where m is our slope and b is our y-intercept. Now, right now, that just sounds like a whole bunch of talk to you, so I'd rather show you instead. Okay, so we're going to take the same equation. Now we use the t-chart to graph y equals 2x plus 1. Now our slope-intercept standard equation is y equals mx plus b. So when we compare the two, we see that in our equation, m equals 2 and b equals 1. So using that information, I plotted my graph here on the right. So I said that b was our y-intercept. So I went over to the y-axis where I saw 1. I plotted a dot. Well, I plotted, a coordinate. And our slope is 2. Now, you know slope as rise over run. So I went up 2 on the y-axis, and I went over 1. Because anytime we have a single number as our slope, we know 1 is under it. Because 2 divided into 1 is 2. But they don't have to put 2 over 1 because it's assumed. So, like I said, I went up 2 over 1. That landed me at 1, 3. And then I decided to do it one more time. I went up 2 and over 1 to the right, and it landed me at 2, 5. Now, as you can see, it looks similar to what we plotted when we did the t-chart, except this went much quicker. It was much easier to do. Now, some things you want to keep in mind when you're plotting or when you're graphing linear equations. When you have a positive m, which is our slope, your line is going to lean to the right. As you can see here on the left, our slope was 4 over 5, positive 4 over 5. And as a result, our line is leaning to the right. However, when you have a negative slope, your line is going to lean to the left. Over on the right here, we have y equals negative 4 over 3x plus 1/2. Since our slope was negative, our line, as a result, is leaning to the left. Now you have completed your refresher on graphing linear equations. If you have any questions, problems, concerns, or you need help with your homework, please do not feel afraid to leave a comment below, or you can email us directly at oppercalculation@gmail.com. That'll be in the description box. But until then, like, subscribe, comment, tell your family, friends, loved ones who might need help with Algebra 1, or if they're reviewing for ACT, SAT, we're here to help. Now you reach Mission Possible, where if you're at home, if you're in class, you can take out a sheet of paper, try these problems. If you have any questions or problems with these problems, again, contact me. We're here to help, and I thank you for tuning into this video.